This video will help you on your 2.1 assignment, Quadratic Functions. So the first type of question is looking for what's called the axis of symmetry. So if you think about your graph and you've got your parabola, let's just draw a quick one here. What the axis of symmetry is essentially the line that makes it about even. So if I were to draw a line, this is a rough sketch down the middle, then this section should be symmetric with this section, and it's called the axis of symmetry. And so the formula that you're going to need, well, really, we'll just go straight to the actual part that you need, is negative b over 2a. So in order to use this, your function has to be in standard form, which remember is 2, 1, none. Should be in decreasing order of your exponents. So if that's true, then you've got a, b, and c. So if I were to write them out, my a value would be what's in front of the x squared, which in this case is 1. Remember, if nothing is there, there's an imaginary, let's not use imaginary, but kind of an invisible 1. Then the b value is what's in front of the x term, which in this case is negative 6. So be careful, because that negative does belong to the 6, so negative 6. And then our c value is what's there at the end with no x term, and it is just 5. And I would do the same thing if I were doing quadratic formula and so forth. So I like to just list out my a, b, and c values. So according to my axis of symmetry formula, it's negative b over 2a. So b right now is negative 6, but I need the negative of the negative. I like to call it opposite b. So the opposite of negative 6 is positive 6 over 2 times a, and we know a is 1. So I'm just going to rewrite this to make it nice and pretty. The top is positive 6. The bottom is 2 times 1, which is 2. So then I've got 6 over 2, which reduces down to 6 over 2 is just going to be 6 divided by 2, which is 3. So my axis of symmetry is 3. Then you're going to be asked to find the vertex when it's in standard form. So it's important because the vertex is still going to be a point. Remember x comma y. You're always going to have your x comma y. Now your vertex, if we go back to our example of the parabola, let's draw 2 of them here. Your vertex is either going to be your highest or your lowest points. So to find the vertex, you're going to start with the axis of symmetry, negative b over 2a. So we're going to do what we just did a minute ago. My a value is the one in front of the x squared term, which in this case again is 1. My b term, in this case again, is actually the same function, so it's negative 6 is my b term, and my c term is 5. So even though we know the answer to the axis of symmetry, I'm going to work it again just so you kind of see the example again. So according to the formula, it's opposite b over 2a. So b is currently negative 6, so the opposite is positive 6 over 2a. A is 1, so 2 times 1 is 2, and we know that's 3. So we already figured that part out. So what's cool and what's going to be a little bit different than what we've done before is we're not done. The axis of symmetry is really the x value of the vertex. So right now, my vertex has an x value of 3. We just don't know yet what the other value is going to be yet. So let's change color and let's put this in. So we know x is 3, so what I'm going to do is I'm going to plug it in to each value of x. So let's rewrite this so you can kind of see it happening live in action. X squared minus 6x plus 5. So instead of x squared, it's now 3 squared minus 6 times x, but we know that x is 3, so I'm going to replace the x with 3, and then plus 5. Okay. Order of operations here, 3 squared is 9. Negative 6 times 3 is minus 18. And I got a plus 5. So really, all that I've done here was just go ahead and put in all the values of x that I needed to plug in, and I worked it out. So now I've got just my constants left, 9 minus 18 plus 5. So 9 minus 18 is negative 9, plus 5 is negative 4. So that value is my y. Therefore, change colors. This whole thing right here is my vertex. The vertex is nothing more than your axis of symmetry value and your y value that you got when you plugged the x value into your function. And there you go. You got your vertex. So the highest point or lowest point of this particular function would be 3, negative 4. And because it's positive, x squared minus 6x plus 5, remember that the first number here, the leading coefficient, is positive. So it's going to make the happy face parabola. So that means the lowest point is 3, negative 4. Okay, so now it's going to say find the vertex of the following function. So the difference between the other one, let's go back. This was in what's called standard form. So notice I even put that here on top of the slide. Standard form again is x squared, x, no x, descending order. Vertex form, remember, is going to have the parentheses here and the square, and then the extra value on the outside. And so the actual formula itself is x minus h squared plus k. Now you might be looking at this and thinking, gosh, geez, I really don't care for this form, but you will because it's super easy if you know the formula. So the reason I like it is this right here automatically. The vertex form, or the vertex of the parabola, just keep in mind in this form is h comma k. Instead of x comma y, it's h comma k. And I remember that off memory because x comes before y alphabetically, h comes before k alphabetically. So my h value here is positive 81, but remember the formula says it should be minus. So since mine has a plus, that means I must have put in a minus because two negatives make a positive. So my h value is negative 81, and my k value is negative 17. So pay attention. So let me show you this again. If I do x minus 2, just like another quick one, my h value, because it's negative, and it should have been negative in the formula, my h is negative 2, my k is positive 2. If I do x plus 2, do the same one but plus, see how this is positive? Because the formula up here has to be negative, I must have put in a negative. So be careful. Be careful. So my h in this case is negative 2, my k is positive 2. But back to my original work here, I knew this 81 was positive, so my h was negative 81, and my k is negative 17. And because we know h comma k is just the vertex form, then I know my vertex of my parabola is just negative 81, comma, negative 17. Okay, then you're going to be asked to write the following in vertex form. So in order to do this, you have to do what's called completing the square. You probably did this in Algebra 2, definitely in Algebra 1. So what we're going to do to complete the square, I'm just going to rewrite it without the f of x part for now. It just happens to throw me off sometimes. I like to do it without it. And we're going to set it equal to 0. And the first thing we're going to do is we're going to minus that 13 on both sides. We only want two terms on the left. So I'm left with x squared plus 6x equals 0 minus 13 is negative 13. Okay, so let's change colors here. So in order to complete the square, I'm down to two terms on the left. I'm going to write that here in case you're taking notes, two terms. So now I can do what's called the Kit Kat method. I just call it that because I like chocolate and it makes sense. I'm going to break this by dividing it by 2. So 6 divided by 2 is 3. Okay, and then I'm going to square that number to get 9. And all I'm going to do is add it here and here. We got to do it on both sides. So again, to recap, I divided the 6 by 2, and I got 3. And then I squared that number to get 9, and I'm going to add it on both sides. So I'm going to end up with x squared plus 6x plus 9. Don't add the 9 to the 6x because you can't. They're not like terms. Equals, and then you had your negative 13 So you're negative 13, and you're going to add the 9 to it, and you end up with negative 4. Okay, so now what do you do? Well, great question. Now, the reason we did all this whole process to begin with is because we made what's called a perfect square trinomial. And so the term that I got here was the 3, right? When I divided by 2, I got the 3. So because it's a perfect square trinomial, what I divided by was 3, and it's a positive in the middle, so it just factors out to be x plus 3 squared equals negative 4. Now, if you don't remember your perfect square trinomials, you can always go old school factoring. Remember the diamond method, the first and the last, or AC method you may have called it, gave me a product of 9, a sum of 6. Those two numbers are 3 and 3. 3 and 3 multiply to be 9. 3 and 3 add to be 6. So my answer is x plus 3 times x plus 3. And those are the same, so we can just write x plus 3 squared. So even if you did it the other way that you probably did a lot of factoring before, you're going to get the same result. So the last step is this. This has to be equal to 0 in order for it to work. So I'm going to add 4 to both sides. I'm going to bring my answer over here for space. So I'm left with the x plus 3 squared, should be plus 3 squared plus 4 equals 0. Now you may be thinking, why did we just go through all this? Or what was the purpose? Well, here's why. Now it's in vertex form. And because it's in vertex form like we did in the last problem, I know my h, instead of being plus 3, is minus 3. And instead of being plus 4, well, it actually stays plus 4. So my vertex is negative 3, comma, 4. And boom, done. So then you're going to be asked to do what's called an application. Anytime you see application, that just usually means word problems, and I know how much you love those. So the height h in feet of an object above the ground is given by h equals negative 16t squared plus 64t plus 190t, or plus 190, where t is greater than or equal to 0, where t is time in seconds. After how many seconds does the object take to reach its maximum height? So the first thing I'm looking for is, what do they want me to find? They want me to find how many seconds to reach the maximum height. So the maximum height on a parabola, because remember you got a square here, so it's quadratic, would be the vertex. Okay, there are a couple ways you can do it. You can do completing the square and put this in vertex form, or if it's in standard form, I like to just go ahead and do our axis of symmetry method. So remember, axis of symmetry is negative b over 2a. So in this case, my a is negative 16, my b is 64, and my c is 190. So opposite b, so instead of 64, the opposite is negative 64, over 2a. 2 times negative 16 is negative 32. Remember that a negative divided by a negative will be a positive. So negative 64 divided by negative 32 will be positive 2. So that is my axis of symmetry. So then how do I find the vertex? Well, I'll take that answer and plug it in for every t. So it becomes negative 16 times 2 squared instead of t squared, plus 64 times 2 instead of t, could be solved for t, plus 190. So 2 squared is 4, so it becomes negative 16 times 4 plus 64 times 2, which is 128, plus 190. I guess I could have gone ahead and did the negative 16 times 4, but negative 64 plus 128 plus 190. Then we'll just go ahead and put all that together. Negative 64 plus 128 plus 190 gives me 254. So the vertex of this parabola is 2, 254. That's the mathematical answer, but we now need to look at it from the real world context. It's asking after how many seconds does the object take to reach its maximum height? So the maximum height itself we know is 254 feet. How long did it take to get there? 2 seconds. So the x value gave us how long it took, the y value gave us how high it went. And that should help you with all your questions that you need for 2.01.